Okay, guys, I'll be sharing my screen. Let's start the session. Okay, so today we'll be learning about hyperbola. We'll be having the second session of hyperbola. So let's first understand what are we going to study. We today will be studying pair of tangents, chord of contact, chord with a given middle point, director circle, diameter of a hyperbola, asymptote, and properties of asymptote. So these are our agenda for today. Okay, so let's study let's start our session. So first of all, let's do a recall test. So, do you guys? I think we couldn't finish this topic. I'll tell you the equation of tangent to the given hyperbola at the point x1 comma y1. Okay, so equation of this is similar to the ellipse. Okay, everything like that we have discussed till now. If you have seen the session for ellipse, you must understand and remember that everything is similar to ellipse and like for hyperbola as well. So for ellipse, if you remember, the equation of a tangent at the point x1 comma y1 was x into x1 upon a square plus y into y1 upon b square equals to 1, right? This was so for equation of tangent to hyperbola, for hyperbola also it is similar. For hyperbola, what is the change? This plus sign changes to minus sign. This plus sign changes to minus sign. So similarly, in the equation of tangent also this plus sign changes to minus sign. It becomes x1 by a square minus y1 by b square equals to 1. So this is what is the equation of tangent in hyperbola at the point x1 comma y1, right? So let's do a question. The eccentricity of a standard hyperbola passing through the point 4 comma 6 is 2. Then the equation of tangent to the hyperbola at 4 comma 6 is. So now this is a very interesting point. Sorry, this is a very interesting question. So this is given as the eccentricity of the standard hyperbola is 2. And the hyperbola is also passing through the point 4 comma 6. So first of all, the standard hyperbola equation is x square by a square minus y square by b square equals to 1. Okay, since this is passing through 4 comma 6, I can write that 4, that is 16 by a square, minus 6, that is 36 by b square equals to 1. So I get the relation between a square and b square. This is one relation. And for me, it is eccentricity. I can write that eccentricity square is a square plus b square upon a square, right? So here from this you can find out the relation between a and b one more time. So e square will be 4. 4 will be equals to a square plus b square upon a square, which can be written as 1 plus b square by a square. So we know that b square by a square comes out to be 3. So b square equals to 3a square, right? So in this thing, in this first equation, see, this is the second equation that we got. We will use this in this one. So what I'll get here is, I'm writing here, I'll get 16 by a square minus b square is 3 times of a square. So this comes out to be 36 by 3 a square equals to 1, right? So this will be 12. So 16 minus 12 by a square will be 1. So a square will come out to be 4. So a square is 4. Similarly, if a square is 4, b square will come out to be 3 into 4, which is 12. So the equation of the standard hyperbola will become x square, x square minus y square by b square equals to 1. This will become x square by a square is 4 and y square by b square is 12, and this is 1, right? Now the equation of tangent at the point 4 comma 6 will be x into x1 minus x into x1 by a square minus y into y1 by b square equals to 1. So this can be written as x into 4 by 4 minus y into 6 by 12 equals to 1. 4 gets cancelled, 6 comes out to be 2. So the equation becomes 2x minus y equals to 2. So this is the equation. This is the equation of tangent that the question is asking. I hope you all understood this topic. Let's move on to the further topic. Now let's solve this question again. A line parallel to the straight line 2x minus y equals to 0 is tangent to the hyperbola at point x1 comma y1. Then x1 square plus 5y1 square is equals to. So this question was asked in JEE mains. How will we solve this? So this, first of all, let's draw the hyperbola to understand. This is the hyperbola 2x minus y. This is y equals to 2x line. This comes out to be something like this. This will pass through a hyperbola. So from this a line parallel to the straight line is tangent to the hyperbola, right? So the slope of this line y equals to 2x, m is 2, right? So this line, the a line parallel to this line is a tangent. So the slope of the tangent will also be 2, correct? Slope of the tangent will be 2 over here, and let's call that tangent line is y equals to 2x plus c. So this line is a tangent to the hyperbola, right, at the point x1 comma y1. So x1 comma y1 is on the hyperbola, so we can say that x1 square by 4 minus y1 square by 2 is equals to 1, correct? So this is one equation. And from this we know that the slope of this line is 2, so we can also find that the slope of the tangent 2x by 4 minus 2y dy by dx by 2 is equals to 1, right? This becomes 2, this becomes out to be 1. So dy by dx is actually x by 2y1, right? It is x by 2y1, right? So sorry, x by 2y, right? So dy by dx at x1 comma y1 will be equals to x1 by 2y1. So x1 by 2y1 will be equal to 2. Okay, so this is the line the slope of the tangent given to us, right? So we can find out that x1 equals to 4y1, right? X1 is 4y1, so x1 square is 16y1 square. So this is also one relation. Let's use this in this becomes 16y1 square upon 4 minus y1 square upon 2 equals to 1. So you get what? This is 4. So this becomes 4y1 square. This becomes 8y1 square minus y1 square equals to 2. So y1 square comes out to be 2 by 7, right? Y1 square comes out to be 2 by 7. So x1 square will be 16 into 2, 32 by 7. X1 square will be 32 by 7. So x1 square plus 5y1 square will be 32 by 7 plus 5 into 2 by 7. This comes out to be 42 by 7. This will be 6. So this value is equal to 6. Now, the equation of the pair of tangents that can be drawn from any point. Earlier, what we studied that this point was on x1 comma y1. This was x1 comma y1 lying on the hyperbola, and we were finding the tangent to this point, right? So we can draw only one tangent. But now we have to find the pair of tangent. Pair of tangent can be possible when you are drawing from outside the hyperbola to the hyperbola, right? So this is the outside the hyperbola region. So from outside the hyperbola, you are drawing the tangents, and this point is given as x1 comma y1. Then what is the equation of pair of tangents? Right. So equation is given by s1 equals to t square. So this equation for pair of tangents was also eligible for circle, right? If you guys remember the chapter circle, this was there in the circle chapter also. So what is s? S is the parabola that is given to us, minus 1. What is s1? S1 is this x square, x1 square. S1 is when you substitute x and y as x1, y1, the points that are given, and t is the equation of tangent, right? T is the equation of tangent when that point was on parabola. So you have to remember this thing. Let's study equation of, let's remember the equation of chord of contact of the tangent drawn from the point. So equation of chord of contact is given by t equals to 0, right? So chord of contact is, this point is here, tangent, this point is here, this is the, so equation of this line is given by t equals to 0, right? So we are supposed to remember what s is, what s1 is, what t is, so we can understand all the formulas. Now in this thing, earlier we were given a point here and we found the chord of contact, right? We found the chord of contact. Now a point is given on the chord of contact, and that point is x1 comma y1, and it is the midpoint. This is the midpoint of this chord of contact. So how we can write the equation? T equals to s1. So now let's find the, let's try to solve this question. The locus of midpoints of the chord of the circle which touches the hyperbola is, so let's first of all this let's understand what this is saying. I am drawing the diagram of hyperbola. This is x square by a square. A square is 9, a is 3, and b is 4. Here the hyperbola is like this. This is a comma 0, 3 comma 0. This is 3 sorry, minus 3 comma 0. This is 3 comma 0. So a circle is given whose radius is 5. So we'll draw like this a circle whose radius is 5. Yeah. So this point, this radius is 5. It will actually pass through the parabola like this. The circle will be a little bigger. Let's erase that circle. So this is how the diagram will look like. Yeah, so this is how the diagram will look like. Now let's understand the question. The locus of midpoints of chord of the circle, right? So whichever chord you are drawing to the circle, and suppose that chord is a tangent, like this chord is a tangent to the parabola, to the hyperbola. This chord will again be a tangent. What else can be there? This chord will be a tangent. This chord will be a tangent. So this is what the locus of all these midpoints of this tangents which touches the hyperbola is we are supposed to find. So locus of midpoints. So let's assume this is a circle. This is the hyperbola. There is a chord that we are drawing here like this, and this is the diagram, right? So this is h comma k. This point is h comma k. We have to find the locus of this point h comma k. So now we know that s is x square plus y square minus 25 for the circle, right? And the equation of the chord is given by t equals to s1, right? So t is hx plus ky minus 25 equals to s1 is x1, sorry, h square plus k square minus 25, right? This gets cancelled. So we get h square plus k square equals to hx plus ky. So this is what we get. Now, now let's compare this to y equals to mx plus c, right? When we compare this to y equals to mx plus c, when you compare this to y equals to mx plus c, you get what? M equals to minus h by k and c equals to h square plus k square by k, right? And for this circle, sorry, for this line to be a tangent to the hyperbola, we know the relation, right? C square is equals to a square m square minus b square. What is c square? H square plus k square by k whole square. H square plus k square by k whole square equals to a square is given as 4 into m square is minus h by k whole square minus 16, right? B square. So solving this, you get what? You get h square plus k square whole square upon k square equals to 4h square minus 16k square upon k square. So this gets cancelled. So the equation, sorry, so the locus of the hyperbola, sorry, locus of h comma k comes out to be 4h square minus 16k square equals to h square plus k square whole square. So this can be replaced by 4x square minus 16y square equals to x square plus y square whole square, right? Now find the locus of midpoint of the focal chords of the hyperbola x square by a square minus y square by b square equals to 1. So what we are supposed to find, this is the hyperbola. A focal chord, what is the focal chord? Wherever is the focus, where is the focus of the hyperbola? So first of all, we will consider here it was the focal chord, here it is the focal chord. So this is the focus point, focus a comma 0, this is minus a comma 0, right? So these are the focal chord, and we are supposed to find the locus of the midpoint of the focal chord. So let that midpoint be p, which is h comma k, right, which is h comma k. So equation of the chord whose midpoint is given, equation of the chord whose midpoint is given is represented by what? T equals to s1, right? So t is what? X h by a square minus yk by b square minus 1 equals to h square by a square minus k square by b square minus 1. So s1 is this, t is this. Minus 1 gets cancelled. Now, since it is a focal chord, it passes through the point either ae comma 0 or minus ae comma 0, right? So let, if it passes through ae comma 0, the locus will be, what y will write here is y will be 0 and x will be ae. So ae comma, sorry, ae into h upon a square minus 0 equals to, this will become h square by a square minus k square by b square, right? So this will become a gets cancelled. So the locus will be x square by a square minus y square by b square equals to e into x by a, e into x by a. This will be the locus when it is passing through minus ae comma 0. So here instead of e you will get minus. So when it is passing through minus ae comma 0, it will become, or we can also write x square by a square minus y square by b square equals to minus ex by a, right? So this is when passing through minus ae comma 0, and this is when passing through ae comma 0. Now what is a director circle? So the locus of the intersection of tangents which are at right angle is called the director circle. So we know the director circle formula. We have studied in circle, we have studied in ellipse, we have studied in now we are studying in hyperbola as well, right? So director circle is what? When you draw tangents which are, you draw tangents which are perpendicular to each other. When you draw tangents which are perpendicular to each other, so this gives us as director circle, right? So the locus is director circle, right? So here also if you draw tangent, if you draw tangent perpendicular, so you have to find the locus of this point, right? So equation of director circle for the hyperbola, you remember equation of director circle for ellipse was, x square plus y square equals to a square plus b square. Similarly for hyperbola it is x square plus y square equals to a square minus b square. Locus of the middle points of a system of parallel chords with slope m of hyperbola is called is its diameter. So what is the diameter? So what locus of the middle points of system of parallel chords? So these are the parallel chords. So whatever will be the locus of these points, this middle points here, 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 this will come, this will become the diameter. So a parabola, a hyperbola also has a diameter. So this equation of the diameter is given by y equals to b square by a square m into x. What is this m? This m is the slope of these lines, these parallel lines. Tangent at infinity. Asymptote, meaning of asymptote is what? See, there is this hyperbola, you can draw like here you can draw a tangent, right? Here you can draw a tangent, right? So this hyperbola goes till infinity like this, right? Like this it goes to infinity. So what we are saying is this hyperbola will have a point, we don't know, it is just grazing through the hyperbola but not touching it, not touching it, not touching it, not touching it, not touching it. But at infinity, somewhere when it is just grazing, it will, like, this distance is becoming less between the line and the hyperbola, and at infinity it touches the hyperbola. We assume that it touches the hyperbola at infinity. So this type of tangent is called as asymptote to the hyperbola. Hyperbola and its conjugate have the same asymptotes. So this is a property of asymptotes. So hyperbola and its conjugate. So x square by a square minus y square by b square equals to 1, and x square by a square minus y square by b square equals to minus 1. These two will have the same asymptote, right? So asymptote, we know that it is a line. Asymptote is a line which is a tangent to the hyperbola at infinity, right? So another property of the asymptote is that the asymptotes pass through the center of the hyperbola. The asymptotes always pass through the center of the hyperbola. For standard hyperbola, it will pass through the origin because origin is the center of the hyperbola. Properties of asymptote. Axis of hyperbola bisects the angle between asymptotes. So what it is saying that this line and this line bisects the angle between the asymptotes. So let's say the angle between the asymptotes this whole angle was alpha. So this angle will come out to be alpha by 2. If this angle was beta, this angle will come out to be beta by 2. So this is what it does. It bisects the angle between the asymptotes. Equation of hyperbola and its asymptotes differ in constant terms only. The angle between the asymptotes of the equation of hyperbola and its asymptote differ in constant term only. The meaning of this thing is that if the equation of hyperbola is x square by a square minus y square by b square equals to 1, then the equation of the asymptote will be x square by a square minus pair of asymptotes will be x square equals to c, right? So it will differ in only terms of constant. So this will be the equation of asymptote. Angle between the asymptotes is given by 2 tan inverse of b by a. So this is something to remember. Now the equation of the asymptotes of the hyperbola. Now this is the hyperbola which has been given to us. Now we have to find the equation of the asymptotes of the hyperbola. First of all, we know that the equation, we already studied that the equation of the asymptotes only differ by the constants, right? So that asymptotes will be pair of straight lines, right? Pair of straight lines. So for pair of straight lines, let the equation of the asymptote be represented by 3x square plus 4y square plus 8xy minus 8x minus 4y plus lambda, right? Since this lambda is only making the difference. So this is the pair of straight lines for asymptotes. We know that property of pair of straight line is that ABC plus 2FGH minus AF square minus BG square minus CH square is equals to 0. So what is ABC? A is 3, B is 4, C is lambda. What is 2 into FGH? FGH, we know that F value is minus 2. F value is F value is minus 2, G value is minus 4, and H value is 4, right? So this is like 2FY, this is 2GX, this is 2HXY. So H value is so 4. Again, A value, AX square, 3 into F square. F value is minus 2 square minus B is 4 value. G is what? G is minus 4 square minus C is lambda, H is 4 square equals to 0. So when we solve this, we get minus 4 lambda plus minus 4 lambda minus 12 equals to 0. So lambda comes out to be minus 3. Right? So the equation of the pair of asymptotes will be here, this thing, this option A, right? Because lambda is minus 3. So find the asymptotes of the hyperbola. We have to find the asymptotes of the hyperbola xy minus 3y minus 2x equals to 0. Right? So this can be written as xy equals to 3y plus 2x. So we can also now pair of asymptotes can be written as xy minus 3y minus 2x plus lambda, right? So the center of this hyperbola is 3 comma 2, right? You can find from this thing, center of the hyperbola is 3 comma 2. So we know that the pair of asymptotes pass through the center, right? Their intersection point is center, right? So this will also satisfy the center. So what I'll do is 3 into 2 minus 3 into 2 here minus 2 into 3 plus lambda equals to 0. So lambda will come out to be, this is 12, 12 minus 6 equals to 6. So the equation of the asymptotes, find the asymptotes. We have to find the asymptotes individually. So xy minus 3y minus 2x plus 6 equals to 0 is the pair of asymptotes, right? This is pair of asymptotes. We have already found that for pair of asymptotes lambda is 6. Now we can write this thing as x minus 3 into y minus 2, right? Xy minus 3y minus 2x plus 6 equals to 0. So the asymptotes are x equals to 3 and y equals to 2. So this is the homework, guys. Please note down the homework. Please note down the homework and try to do the homework. Take a screenshot if you want, and then we will end the session. Thank you so much for attending the session, guys. Have a good day. Take care.